welcome back to SanfordFlipMath. This is PreCalculus. We are working on transformations. This is all kind of keyed in with the Demana, Waits, Foley, Kennedy PreCalculus book, PreCalculus Graphical Numerical Algebraic. And we're in section 1.5, and this is transformations. Don't freak out. We will pop back to section 1.4. I just prefer going to section 1.5 first, dealing with transformations, and then we'll go back. This is a follow-up lesson to 1.5a, where we kind of introduce some notation and some vocab about moving things around. And with this screen, I basically want to just kind of recap some notation here, and I'm not going to do any graphing on this particular one, but just so you understand again. So looking at this first one, if I start with a parent function of y equals x cubed, all right, I'll do a little sketch. It would look something like that. And just a reminder that anything dealing with multiplication or division needs to be dealt with first. So I see 2 attached on here. So we are actually looking at how does this 2, how does the plus 3, how does the plus 2, how do all of those things affect the shape or look of this graph. Okay. So this 2, remember that anything on the outside deals with y, which is vertical. And remember that you do what it says. So in other words, if this says times 2, then we're going to multiply by 2. Ultimately, when that says plus 2, we will add 2. Okay? All right, so this 2 is multiplying all of the y values by 2. Now, a mapping notation for this would look like this. So this is a scale change. So that's why it's S here. Okay. Whoop, too much. Sorry, let me put that back. And that too. All right, that's fine. So that's a scale change, and it does not affect the x's, but it does affect the y's, and they are multiplied by 2. Okay. You could word this, you know, if we said it in words, it is a vertical stretch of factor 2. Okay, and again, what that means is that all of the y values, vertically that is, are multiplied by 2. Okay, and just a smidge more with this. Okay, anything that's about addition or subtraction is a translation. In other words, a slide or a shift or a move, or any other word that means the same thing. Okay, so and anything that's inside, it's about x, it's horizontal, because it's about x, and you do the inverse. Inside, inverse. Okay, so as we look at that plus 3, so this is about addition and subtraction. So this is a translation which maps all of the x, y's onto, well, the inverse of x plus 3 would be x minus 3. The inverse of addition is subtraction. So inside, inverse. The y values, there's a plus 2 on the end there. Well, y, if it's on the outside, it's about y, it's vertical, do what it says. So there's a plus 2. So there are actually 2 things, well, 3 depending on how you count them. There was a scale change, x to y. In other words, the x's didn't change because of the scale change, but the y's were doubled. And there was a translation, 3 to the left and 2 up. And so if you're going to say that in words, there was a shift, a slide, however you want to word it, left 3 and up 2. Okay, worth noting that if you were going to do that, you need to talk about the multiplication first. So vertical stretch of 2 and a shift left 3 and up 2. Okay. One last thing about this, and that is we can put those 2 notations together again, and that is a linear change. And anytime you have a combination of something to do with multiplication or division, as well as addition or subtraction, you can put that together linear. So again, the idea is like mx plus b. And so the only thing happening to the x was x minus 3. Y's, well, they were doubled, and then 2 was added to them. So this is a way to do all of that at once. Okay, so, and we'll go with this kind of aqua bluish thing to go there. Okay, all right. Now, if you recall, up at the top of the page, I have this other thing. Well, and this is a very generic f of x. And the idea is that sometimes we end up starting with just a graph that really doesn't have an equation. Okay, for instance, something like this. It'd be very difficult to graph this in the calculator because I don't have a function to put it with it. So sometimes what you'll see is notation that looks like that, like what we have here. And again, the idea is this is a parent function, and perhaps it's already graphed. And then what I want you to do is create the graph of this based on that parent function. Well, what I need you to understand is what we just did over here is the same exact thing. Notice there's a 2 on the outside. So that's vertical stretch of 2. It's outside, it's about y, it's vertical. You do what it says. Okay. There is addition on the inside. So there is a horizontal shift left of 3. There is a vertical shift up of 2. This is the exact same stuff we just said a minute ago on the other side. I just need you to understand that there is an inside again, and there is an outside. So this is outside, this is outside. And in this case, the inside is inside that f of x notation. Okay, so just so I kind of finish my, I should have done this a second ago, sorry. Okay, so this is outside, again, about y, do what it says. This is inside, it's about x, do the inverse. Okay? All right, so that's kind of my quick little recap, and you can feel free to go back to the other video, 1.5a, for more of that. Okay, we're going to next go to just another equation. So let's do -2 square root of x plus 3. Okay, so what we want to do is figure out what happened to the parent function. Well, I guess first of all, we should probably identify what the parent function is. Okay, now remember, a parent function is the simplest version of a function that has the same basic features about its graph and domain and range and that kind of stuff. And that would be square root of x. Okay, so I'm going to do a little sketch of the parent function. I'm not spending my life on it. I happen to have a grid here, so I can actually do this fairly quickly. So that's the parent function. Okay, I need to now look at, and it doesn't matter whether you deal with outside or inside first, but remember we do want to deal with any multiplication or division first. Okay, so on the outside, and again, anything on the outside of that square root, that radical, is the outside. On the outside, we are multiplying by -2. Well, outside is about y's. Do what it says. So that means the y values are going to be multiplied by -2. So this is a scale change that maps x and y onto x, -2y. Now, inside, and really that's pretty much it. Inside, it's a translation, and this is inside, so it's about x. It's inside, so it's inverse. It's not doing anything to the y's. There's no addition or subtraction. So remember, translations are about addition and subtraction. Scale change is about multiplication and division. Okay, that's the moment here. I'll do an x for multiplication. Now it's an x and a dot. Okay, I'm not sure what to do with that now. All right, and if you prefer to put all of that together, the linear transformation would be x minus 3, -2y. Okay, so we didn't do anything with the graph yet, so let's do that. Now, me personally, I wish this would have been in black. How about that? I'm going to change it because I'm sweet like that. All right, parent functions up there in black, and we'll do the scale change in red. Now, what this means is all y's are multiplied by -2. I guess I wrote that before. Well, this y value is 0 times -2 is still 0. This y value is 1. I'm going to multiply it by -2. This y value is 2. I'm going to multiply it by -2. And I'll do a little sketch. Now, worth noting that this is not my final image. All I did so far was that scale change. Okay, that's all I've done. Now, this part says I'm supposed to shift left 3. Well, I want one graph that does all of this, so I'm going to take the graph I just made, that stretched graph. Okay, so that was a quick little note here. If we go in words, this is a vertical stretch of 2 and a reflection over the x-axis. And so the question was, what caused that reflection? It was the negative. Okay, all right, back to the shift, the move. Going left 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. Sketch, 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 sketch. Oh, that's beautiful. Okay, now one little word of warning. If you're doing this on a test or quiz, make sure that your final answer is very obvious. And why did that just do that? That was weird. All right, let's try that again. Okay, so that's my final answer. Again, I have linear notation or a combination of scale change and translation notation. So you can do either both of those top ones or the linear. And again, if it said it in words, then we have done a vertical stretch of 2. We have done a reflection over the x-axis, and we did a shift left 3. Okay, so that's it. Okay, next up. Okay, go back to that as many times as you want. Actually, what I would like to do is not have that highlighted, but that doesn't matter. Okay. Why is that like that? Sorry, wasting time. All right, what I want to do next is I want to say we're going to write an equation with a parent function y equals the absolute value of x that has a horizontal stretch of 3, so it's making it bigger, and shifts, let's say down 2. Okay, so we're going to write an equation that does that. Horizontal stretch, well, if it's horizontal, it's got to be inside, and it has to be inverse. Okay, stretches come from multiplication, but I have to do inverse on the inside. So basically what's going to happen here is that x is now going to be x divided by 3. Again, if it's horizontal, it's inside. It has to be inverse, so a stretch of 3 means we would multiply the x values by 3. Okay, if we were going to have notation for this, it doesn't ask for that, but if we were going to have notation for this, it would look like that. So inverse inside, multiplying by 3, so dividing by 3. Okay? And shifts down 2. Shift is about addition or subtraction. Down is vertically, so it's about y, so it's going to be on the outside. Do what it says, so if we want down, we're going to subtract 2. So minus 2. Okay, and one other thing, please note it says an equation, so I need a y equals or an f of x equals or something like that. And there it is. That's exciting stuff right there. I can tell you're excited, even from this end. Okay. All right, well, I guess that's as much time as we have. I wanted to limit this to just 15 minutes, so we did a few examples, did a little bit of a recap of what happened, and I appreciate your attention, and we'll see you in class. Bye.